Alright, so looking at our 6.2 circular motion homework, the first question we have here is involving uniform circular motion, asking what direction the force is that acts on the clothes in the spin cycle of a washing machine. So we have our washing machine here going around and around. Something is causing those clothes to keep moving in a circle. Otherwise, they would just go off in the tangential direction anytime they get the chance. And in fact, that's what the water does in the cycle. The water gets inertia, takes it in the tangential direction, but something's keeping the clothes moving towards the center. And the thing that is causing that force is the walls keeping the clothes in the washing machine. So our answer is toward the center, and the object exerting the force would be the walls of the machine. So that's our answer for number 16. For the second question here, you're sitting in the back seat of a car going around a curve to the right. So if you're moving in the car here and you're making this turn, your inertia is going to want to carry you in that direction, even though the car is pulling you to the right with it. So the direction of your acceleration, again, is kind of to the center. The force is bringing you to the center. If you kind of imagine this track being an entire circle, it's bringing you to the center at all times. It's bringing you to the center of the circle. So that's also the direction of the net force. So the acceleration is to the center. The net force then is also to the center, or you could say to your right, since that's pulling you towards the center of that circle, that imaginary circle. And what's exerting this force? Well, that would be a normal force that's exerted by the side of the car or the car door, or hopefully your seatbelt pushing you into the center. So we'll say normal force of the door if you're not wearing your seatbelt, or if you are wearing your seatbelt is simply going to keep you locked in. Alright, so for 18 we have a question involving centripetal force. So remember, centripetal force is simply your mass times your centripetal acceleration, and we know that centripetal acceleration is our velocity squared divided by the radius of whatever circle the object is being moved in. So we have in this case we have a 40-gram stone being whirled around horizontally on the end of a 60 meters string at a speed of 2.2 meters per second. So my mass, I'm immediately going to convert that into kilograms. So 40 grams is going to equal 0.040 kilograms. The velocity, 2.2 meters per second, and the radius of the circle that the stone is being whirled in is going to be 0.60 meters. So simply, let's make centripetal force equal to m times AC, which is v squared over r. So we take 0.040 times v squared, 2.2 squared, over 0.60, and we're going to get 3.2 newtons. So remember, my force is going to be measured in newtons. So in this case, in number 20, we have a very similar situation. I have a bowling ball with a mass of 7.3 kilograms. I'm moving it around a circle with a radius of 0.75 meters. And the speed I'm giving it is 2.5 meters per second. I want to know what kind of centripetal force I have to put on that bowling ball to keep it moving in a circle. So again, centripetal force is m times centripetal acceleration, which we can also write as m times v squared over r. The force required would be 7.3 times 2.5 squared over 0.75, and we're going to get 60.8 newtons for the force that would require that ball to stay moving in a circle. For number 36, they're asking, can you go around a curve with the following accelerations explained? With zero acceleration, that is not possible because the act of going around the curve requires you to change your direction. Acceleration is a change in velocity, which involves speed and direction. So you can't go around a curve with zero acceleration, but you can go around a curve if a constant centripetal force is acting on you with a constant acceleration. So A is not possible, but B is possible. For number 38, if you whirl a yo-yo about your head in a horizontal circle, in what direction must the force act on the yo-yo? Again, since you're whirling it around in a circle, keeping it moving in that circular path, the force has to be directed toward the center of the circle. And what's exerting the force is, of course, the tension force of the string pulling on the actual yo-yo itself. In that case, the tension force is what's acting as your centripetal or center seeking force.